Software. It's in everything we do. It's part of our daily life and it runs everything around us. New software is created every day, faultlessly, seamlessly. It can easily be remolded to new business needs, new processes, and ever-changing customer requirements. The last software failure of any note took place 7 years ago in 2033, and it made the front pages of all major newspapers. Such things just don't happen anymore. But it wasn't always like this. In fact, the development of the modern software industry looks like that of every other major industry. If we look back at the waves of industrialization that paved the way to today's technology, we can see that every modern industry essentially started as craftsmen and amateurs, often with very little formal training and management. They would start each project from scratch, and as they built expertise, through apprenticeship and then experience, over time they would learn how to create consistent quality product. Inevitably, as these industries became bigger and more important to society, commerce, and the economy, every one of them became more automated. Their processes of building product matured. Their output gradually became more consistent and measurable, while productivity multiplied. Consistency and reliability then led to true maturity, where the industries started to measure their processes and focus on quality in order to optimize. This happened for most industries in the late 20th century.
We have learned to live in a world of mistakes and defective products as if they were necessary to life. It's time to adopt a new philosophy,
said Dr. Edwards Deming, one of the industry luminaries who helped establish the Six Sigma and lean manufacturing principles of that era.
What doesn't get measured doesn't get managed,
said Jack Welch, the pioneer in the application of Six Sigma techniques to all business processes in addition to just manufacturing.
I think you could say that Henry Ford invented the assembly line for the car and that Toyota perfected it.
As a consequence of Dr. Deming's projects in Japan, Toyota had overtaken Ford and GM as the global leader in automotive manufacturing by the start of this century. While Ford began industrialization of the automotive industry, Toyota completed that process by building quality in, all the way through the supply chain, thereby improving their margins and marketing a better product. The same pattern was repeated in the software industry. First, computer and software engineering was an elite science. It was only available to governments, university research centers, and to the largest of corporations. Programming a computer was a process that involved many technicians to physically rewire the system. The tasks that computers managed to perform were simple, such as making sophisticated calculations quickly or just tabulating large quantities of data. As capabilities grew, computers became more widespread and software development started to become important as a profession of its own. As the industry progressed, software became more and more the critical piece of infrastructure that drove business. Building software applications for business seemed different than other manufacturing. It required casting complex business processes into pieces of software infrastructure. This took a great deal of intellectual effort, while these software applications became the most important assets of the business itself, codifying the mechanics of the business into digital blocks that took many man-years to build and perfect.
Keeping you up to the minute, a massive computer failure at United Airlines means problems for all 3,600 United Airlines flights.
Back then, around the start of this century, the notion of business application quality was not yet developed, causing systems to get unbelievably complex, hard to maintain, and brittle when put under strain of day-to-day business. Naturally, costs exploded, projects became harder and harder, and critical software underpinnings began to break. Statistics mounted about the staggering costs of application software malfunction and the dire results of attempting large software projects. To address ever-increasing requirements, costs, and resource constraints, companies began to outsource software development, often to India and other countries where cost was lower at the time. So just like manufacturing before it, software development became a supply chain-driven industry, a critical step in its industrialization. Services-oriented architectures introduced more and more interchangeable off-the-shelf plugins. Just as it was to manufacturing, component interchangeability was another key driver of software industrialization. In fact, both sourcing and componentization, though intended to drive costs down, initially increased the complexity of building business applications. Inevitably, this propelled the software industry to follow the same course as other professions before it, introducing process discipline, measurement, and quality into software assembly. Just as in prior technology-driven industries, industrial maturity didn't really come until the notion of managing business application quality became further developed. It was in the first decade of this century that the IT industry understood that technical quality of applications could be managed separately from functional requirements. This unlocked a floodgate of management initiatives to make application development more productive and consistent.
And so the easiest way to screw up that back end, which is the majority of the work that I'm doing, right, is it's to deliver bad technical quality code.
Around the same time, some Lean and Six Sigma concepts from manufacturing were already being tailored to the construction and enhancement of business software. It was the ability to automatically assess the technical quality of applications that turned into the critical enabler for such initiatives. Now, lean manufacturing could truly be applied to the previously craft-like intellectual process of software assembly. Assessments of technical quality started to become more mainstream, especially as the IT industry embraced the fact that application quality is something that doesn't need to be left to chance.
Suddenly, everyone realized that we can be proactive about our custom software. Instead of trying to test quality in at the end, we could use application intelligence all along the assembly to ensure that the hundreds of developers building software for our business were doing it right the first time. We just stopped leaving quality to chance.
Over the ensuing decades, the ability of the software industry to deliver high-quality product on a consistent basis transformed dramatically, and productivity of software development in the business world grew exponentially, just like prior professions as they industrialized. Today, we've come to expect software development to be completely predictable. There is no more craft in building complex business systems, but it's a professionally managed operation. When we start on a big project, we expect that it will be delivered on time, on budget, and with all the required functionality. And of course, we take it for granted that software just doesn't fail, like bridges, buildings, and our power grid. It's like anything else we've come to rely on, our infrastructure for business and for living.